Great. So the paper I'm going to present on is reactivity of alpha rhythms to eyes opening is lower in athletes than non-athletes. And this is a high-resolution EEG study. And so first off, what it means by being a high-resolution EEG study is that we're looking at 56 electrodes and at a really high frequency. And so I'll start off with the background. This paper was done by Del Percio in 2011 and his colleagues. Del Percio has done a lot of research regarding the neural efficiency hypothesis. And the neural efficiency hypothesis essentially stipulates that experts show lower cortical responses during tasks related to their expertise. Okay, so it started off by looking at individuals who have done well in IQ tests and then having them perform cognitive tasks while under an EEG compared to those who don't perform as well on an IQ test and perform those cognitive tasks. And what you see is lower cortical activation in those who score well in their IQ. And then there's a lot of neuroimaging studies that have been done, particularly cognitively in individuals, including, and we'll get to that, positron emission topography, functional magnetic resonance imaging, and single photon emission computed topography. So PET, essentially, the way that works, it's biological tracers assessing metabolism. And so you put a tagged sugar, you'd inject that into an individual, then you'd figure out where it's going and what it's doing. The same with SPECT, except SPECT measures blood flow instead of metabolism. Particularly in this paper, though, we're not looking at individuals and their IQs, we're looking at athletes. And so once EEG was brought into the mix, Del Percio and there are others in the literature who have done this research on athletes have shown that expert athletes also experience lower cortical activation during a resting state or during some part of an easy task, right? And so to break this down, essentially the literature is still rather controversial regarding the neural efficiency hypothesis. There's literature that supports the hypothesis cognitively and with athletics. Del Percio cites himself a few times with some of his research he's done a while back, particularly with expert athletes doing karate and fencing that were either in a sitting and resting position or were in a standing upright position in a difficult balance, and showed that cortical activation was lower in those expert athletes than they were in non-athletes. But the hypothesis is also challenged. So EEG studies have shown conflicting data. And the same came of some neuroimaging studies among individuals with high IQs. And so they've shown that there's actually more prominent cortical activation in athletes or individuals with high IQs during a resting state. So with that background to keep in mind, the particular study that I'm citing that essentially opposes the neuroefficiency hypothesis was done with individuals given a no-go or a go command, and they essentially had to stand up. Okay, so particularly with this paper looked at 18 elite athletes and 28 non-athletes. These elite athletes were part of the national Italian team for Kung Fu, and so for karate, I'm sorry. And so they practiced for about 12 years, and they were also right-handed. And so these EEG recordings were conducted under resting conditions for eyes closed versus eyes open states. It was done with 3 minutes eyes open, 3 minutes eyes closed. It was conducted in the early morning for consistency, and the experimenter was observing the EEG traces online, so while the experiment was happening, and made sure to alert the subjects in the case that they were drowsy, or in the case where you can either see them being drowsy or you see their EEG start dropping out of the alpha rhythms. And so like I said earlier, there are 56 electrodes. The data was fragmented into epochs of 2 seconds, and so it's just fragmented into 2-second segments. Artifacts were identified and eliminated, so anything that didn't fit into the alpha rhythms that we're looking at, which is 8 to 12 hertz. And then the statistical analysis, the data undergone Laplacian transformation, which is some arithmetic, I believe, and was then entered into EEG power spectrum analysis. Okay, so technical difficulties overcome. Moving on from those methods. So these are task-related decreases and task-related increases, and they were measured in a very similar fashion as if they were event-related desynchronization or synchronization. So in a lot of the literature that you would read regarding some of the research we're doing, you would see something like an ERD, right? And that's an event-related desynchronization. So something like they opened their eyes, or they had to take on a task, or they were undergoing some sort of task. And so this is the equation they use to measure the decreases and the increases. And really, all that means is it's the alpha power density associated with the eyes open state or the eyes closed state. And so before I dive into the immediate results, one thing that was very important is they did do t-test. They did t-test the populations and account for gender differences and age differences. And they found that there were no significant differences that existed due to age or gender, but they do talk about undergoing some additional statistical analysis just to ensure that it didn't interrupt their data as a whole, or their results as a whole. So this is their main result. And essentially it shows that karate athletes have lower cortical activation, or better to say, lower alpha rhythms, right, than non-athletes at both the eyes closed state and the eyes open state. Another important note, and I'll go into this later as to why it was so important, is that the eyes open state has a lower alpha rhythm than the eyes closed state. And so if you look at the specific electrodes, you can see that some of these electrodes, that's not true. So I mean, this isn't uniform across, but generally the alpha rhythms in the eyes open state were lower than the eyes closed state. And so the low frequency alpha is 8 to 10, and the high frequency is 10 to 12. And all throughout you can see, or almost all throughout, you can see that karate athletes have lower alpha rhythms than non-athletes. And so the eyes open condition demonstrated lower alpha rhythms than eyes closed condition in all data sets. And essentially they say, because this is what they found, and this matches the literature, that their data was good, right? And so this was their confirmation of good data. And then they went on to say, well, the rest of our data, or the data as a whole, is in agreement with the neural efficiency hypothesis. And so this paper supports that hypothesis. But then we can start going into some of the really complicated and confusing parts of the neural efficiency hypothesis. And that is visual processing of information may ultimately determine that level of cortical activation. If you looked at some of the literature, some of the other literature that opposes the neural efficiency hypothesis, you'll see that, or at least this is the argument Del Percio makes, that those visual motor complexes are a lot more complicated than just sitting down and keeping your eyes open or closing your eyes. And so, depending on the visual motor complex you're looking at, cortical activation could either be more efficient, like the neural efficiency hypothesis stipulates, and be lower, or it can be more complicated and result in more prominent cortical activation. And so, some of the possibilities for the future of this research, well, Del Percio in his paper talks about evaluating the neural efficiency hypothesis and keeping into account athletes that have high intensive visual motor training. And then of course there's our research, which correlates EEGs to heart rate variability, essentially brain health to cardiovascular health. This is the correlation we're trying to make. Now in Del Percio's paper, he does talk about how they don't really understand what this means. And that's going to go into my criticisms. And so the first part of the criticism essentially is that I noticed there's a lot of self-citing. A lot of Del Percio 2011 citing 2009, 2010, 2008. And while that may be really good for his impact factor, I don't think that was a great contribution to the paper, because Del Percio is in support of the neural efficiency hypothesis, and the only time papers that were cited that oppose the neural efficiency hypothesis were when he said, well, these papers oppose the neural efficiency hypothesis, so look at Hung, for example, in 2004. So I don't think that really supports the neural efficiency hypothesis so much more other than his papers and Babyloni's papers that he cited often again. But that aside, let's check the bias and go back to the data. What does neural efficiency hypothesis tell us, especially in the scenario where the paper admits that complicated visual motor complexes, right, could actually stimulate the frontal parietal lobe more in expert athletes than in non-athletes? I mean, what does that really end up meaning in that scenario? Then how does that not debunk the neural efficiency hypothesis in the case of looking at experts or expert athletes to non-athletes? Now, that's not to say that the neural efficiency hypothesis doesn't exist in one way or another. I mean, there's a lot more consistency in the research done cognitively in individuals who perform cognitively better than others. But it does say a lot about the complications of this hypothesis and trying to extend that into the athletic world and trying to figure out where exactly all of these different parts come into play, particularly with looking at expert athletes that perform almost simple tasks and you see lower activation, or expert athletes that have to perform complicated tasks and you end up seeing a lot more energy being used up in those cases. So, are there any questions? Any of the grad students?
I do have some questions. Is the alpha band the one more related and more relevant to the cognitive performance as well? Or is there any band that is more related to the cognitive?
To the cognitive.
Yeah.
So there was some EEG research on cognitive.
And what bands do they use? Which bands do they use?
They did in this paper. They didn't explicitly say that they used the alpha bands, because they did say that they were undergoing some sort of task. And if they were undergoing some sort of task, I would imagine that it would be beta bands they would be looking at in that scenario, not the alpha bands.
And which band is more related to neural efficiency? And is neural efficiency more related to cognitive or to...
So neural efficiency, I think it's not so much related to any particular band. I think they're just trying to make the association that cortical activation is lower in certain scenarios, and they chose in this paper to measure cortical activation through EEG alpha bands instead of any other bands, probably because you can probably easily put somebody into an alpha wave state just by telling them to sit down and rest, compared to consistently trying to get somebody into a beta state, I'd imagine. But neural efficiency hypothesis, the research behind it spans beyond the EEG and into neuroimaging as well.
What I was reading is that the alpha waves are the easiest ones to detect too. Like they're the cleanest of all possible waveforms you could be looking at.
Okay.
That might be a reason why they decided to use those.
Another criticism I had for this paper, and it could be a possible criticism for our research also, is stating that because the alpha rhythms, because the data set in the sense of eyes open versus eyes closed reflected that of the research, that the data set is a good data set. And I wonder if that is questionable to say, well, just because eyes open, eyes closed is consistent, doesn't mean that the data set is a good enough set to say that it's consistent with the neural efficiency hypothesis. So then if we go to our research, I know we're using that as an indicator, but are there any other things that we can look for that say, well, that can put that into question, or that can better validate our data set?
Yeah, I think there is, but I have no idea what to come up for it. Maybe Sharon does.
Yeah, and maybe
it would be very hard and lots of work to validate it, I imagine. Another question that I have comes from that. Why do you think, or did they explain why the alpha level, the alpha frequency was higher when your eyes were closed? Why did that happen? Is there any physiological mechanisms for that?
You know what? They didn't talk about that in this paper, and I should have probably looked at some of the other papers before this that would have done that research. But that's interesting, especially since they're talking about visual processing, right? I mean, wouldn't you process less visual information with your eyes closed, and as a result have less cortical activation as a result compared to eyes open?
I was looking into that one too. There was a little bit in that book, and I didn't get really deep, so I don't want to say it was 100%. What it sounded like what was happening was when you close your eyes, your mind switches basically where it's receiving its visual information from, and so it starts pulling it from that cortical spot right there. So it activates when you close your eyes. When you open them back up, it goes back to whatever the normal routine was. And I think that study, I think it was that one where they had the athletes stand on one foot or do something that was really physically complex. And there was like when they did that, even though their eyes were open, their cortical center still activated. Like,
yeah.
Lit up.
That was the paper right before this paper,
Okay.
and he did cite that in this paper. Well, thank you guys. The only last part was, I was just going to say, I'm going to write my literature review on the neuroefficiency hypothesis because I'm really curious to better understand all of these different complicated widgets involved with this and see if I can make some sense out of it, because as of right now, from this paper and the other paper that I read, it kind of seems like there's not too much direction with the hypothesis, as in what does it end up meaning in the long run.
So do you guys think that's pretty reasonable to find 5 articles for next meeting on the topics that you guys agree?